Welcome back to the course entitled Symmetry, Stereochemistry and Applications. In the first two lectures in this course, we have discussed about the rules of IUPAC nomenclature, and I have described almost all the rules that one need to know how and then start writing the names of different organic compounds. So, in today's lecture, we will take a few examples and we will try to apply our understanding of IUPAC nomenclature for some simple organic molecules. So, let me draw the first molecule on board. Along with me, you also should draw these molecules using your pen and paper, so that you can understand it better. So, what are the functional groups that we are seeing in this particular molecule? We are seeing a few double bonds and there are some alkyl substitutions. So, the first point in this case would be to identify the longest chain, and we should identify the longest chain in such a way that the double bonds gets the lowest numbering and you have the maximum number of branches, and in addition what you should have is the branches or the substitution should have the lowest numbering as well. So, considering all that points, you will understand very easily that the numbering should start from this carbon atom at the top right hand corner. So, we should number it like 1, 2, 3, 4, 5, 6, 7 and 8. So, when you find that this molecule has 8 carbon atoms and in the main chain from 1 to 8 there are 2 double bonds. So, by nature this is a diene. So, the last part of it would be diene. Then we need to find out what are the various substitutions that are present. So, what we see here, we have methyl groups at 2 and 6 positions. So, we should write that as 2,6 dimethyl, and then at 4 position we have ethyl, and then at position 5 we have methylidine, and then what we have is at 3 position. At 3 position we have ethinyl. So, what should be the name of this molecule? We need to alphabetize these substitutions and write the name accordingly. So, when we try to write the name, we should write it as I am writing here 3 ethinyl, 4 ethyl, 2,6 dimethyl, 5 methylidine, 1,7 diene. Hope you are able to follow this nomenclature. Now, I would like to draw a different molecule where we have a cyclic ring system present in the molecule. So, what we have is a cyclohexane moiety. Along with that, I have a slightly long side chain like that. A second molecule of similar type is, I am drawing here, has a slightly different connectivity. What are the names of these two molecules? So, in the first case, what we have is a cyclohexane. That is the main compound, and we have a side chain which has 3 carbon atoms. Sorry, I have drawn it, I have not drawn it right. So, this has 4 carbon atoms connected. So, this is a group of butane, or rather butene, and what we have at 3 position is ene. So, it is 3 butene. So, what the name should be? We should have the butene written as but 3 ene, and this but 3 ene is connected to the cyclohexane ring through the atom 1. So, it should be 1-yle cyclohexane. See the nomenclature what we have done here. We have first found out the cyclic chain and numbered the side chain in such a way that the connectivity of that side chain with the cyclohexane ring gets the lower numbering, and then we have written the name of that side chain as this. So, using the same method for the next molecule, again we have it as a cyclohexane, and a butene, but the connectivity is different. So, if we write it like that 1, 2, 3 and 4, the connectivity is through the carbon number 2. So, you can easily understand that the name of this compound should be but 3 ene 2-yle cyclohexane. So, this is how one should number a cyclic compound with a complicated chain outside the molecule. Then let us try to draw a different molecule where we will have a double bond and also an hydroxyl group present in that. So, what should be the name of this compound? We should start numbering in such a way that hydroxyl group, which is a higher priority group, should get the lower numbering. We should start numbering this molecule from the right hand side such that the oxygen gets the priority number, the atom number 2, 3, 4 and 5. So, this is a derivative of pentane and it has OH group. So, it is pentane 2-ol, and then you have a ene, that is double bond at 3 position, and that double bond at 3 position is nothing but E, which means it is trans. So, we should write it as 3E pent 3 ene 2-ol. So, it is 3 pentanol or pent 3 ene 2-ol with 3 for E, that signifies the geometry across the double bond. and then we try to name another molecule which is similar to the previous two, but it has two different substitutions, one methyl group and second one as a side chain like that, which is a butane or butyl group. So, what we should do here, this is a cyclohexane, but then we need to identify the carbon atoms of cyclohexane by numbering, because there are more than one substitution on the cyclohexane ring. So, the carbon containing a larger group gets number 1 and the second group gets number 2. So, what we have is a 2-methyl, and what we have is butane and 1-butyl group, where you should number that chain as 1, 2, 3, 4, and the connectivity is through the carbon number 2. So, it should be written as butane 2-yle. So, therefore, the name of this compound should be, at position number 1, I have butane 2-yle dash 2-methyl cyclohexane. So, this is how one should logically follow the rules that we have learnt in the first couple of classes and try to write the names of different organic compounds. Now, look at the next set of molecules, which are very interesting, because they all look very similar, but their numbering schemes are going to be slightly different. So, the first molecule that I am drawing is like this. The second molecule that I want to draw is the following. And the third molecule that I should try to draw is this one. So, what we see here in the first molecule among these three, we have this ethane moiety, which can be numbered as 1 and 2, and then here on the 2 position we have a methoxy group. On nitrogen we have 1 ethyl and 1 methyl substitution. So, the name of this molecule should be N-ethyl 2-methoxy N-methyl ethanamine. In the second case, on the right hand side, we have inside a 2 carbon chain, and here there is a 3 carbon chain. This 3 carbon chain gets priority, and that makes this as propanamine instead of ethanamine, and we have this group as a substitution on nitrogen and that group as a substitution on nitrogen. So, we write the name of this group as 2-methoxyethyl. This group is methyl. So, what we should write the name as N-2-methoxyethyl N-methyl propan 1 amine. So, what we have is, here we have 3 substitutions getting priority over 2 substitutions. The third molecule of this series is similar to the second molecule. Here also in the middle we have 2 carbon atom chain, but on the nitrogen I have a 3 carbon atom chain. So, this is again a propanamine, but not like the previous one when it is propan 1 amine, it is propan 2 amine, and this group remains as it is, and I have N-methyl as it is. So, the name of this molecule should be N-2-methoxyethyl N-methyl propan 2 amine. So, you see, depending on the molecule and their number of carbon atoms, we need to identify which is the parent molecule, and based on that parent molecule we need to identify which one is a substitution, and then we write the name of the substitutions correctly the way we are writing here, and then we write the name. If you look at these 3 molecules, all the 3 molecules have a group like that. But the way we write the name of that group in these 3 cases is different. In the first case, we write it as a methoxy group, because the other 2 carbon atom forms the parent chain. In the second and third example, the entire group is a substitution on nitrogen and the parent chain is something else. So, one has to really look at the molecule and try to identify which is the parent chain and which is the substitution on a parent chain. Now, let us draw 2 more examples containing cyanide group. So, what is the difference? In one molecule, you have only one functional group, that is the CN or the cyanide group. In the other molecule, you have 2 functional groups, one is carboxylic acid and the other one is cyanide. So, in the first case, we should write it as, the numbering should be like 1, 2 and 3, and we write it as 2-methyl propan nitrile. Because here the cyanide is the only functional group, so we write it as nitrile. On the other hand, for the second molecule, we should number it as 1, 2 and 3, leaving the carbon connected to cyanide as substitution, and the name of that molecule then should be 3-cyano 2-methyl propanoic acid. So, when cyanide is not the only functional group or the main functional group, we write it as 3-cyano, and when it is the only functional group or the main functional group, we write it as nitrile. Now, we again go back to a simple molecule which is essentially a diene, but here I would like you to see that the two double bonds that are drawn, one of them is E and the other one is Z. So, this double bond is in the Z configuration and that double bond is the E configuration. So, which one should get priority and from which side we should number the atom? Of course, Z gets priority over E. So, as a result, we number the atoms from the left hand side. So, what should be the name? The name of the molecule should be, first we should identify the stereochemistry about the Z axis, about the double bond. So, it is 2Z 4E hexa 2,4 diene. So, here what we learnt is that the Z being higher priority, the numbering starts from the side where Z comes first. Now, we try to see what happens when you have a combination of carboxylic acid, alcohol, some double bond and an aldehyde present all together in a molecule. So, I am trying to write the molecule which is bit complicated. So, what we have is acid, a ketone, one alcohol, this is connected to a double bond and then you have a C double bond O H CO2H. So, by looking at the molecule you can directly identify that this is a dicarboxylic acid. So, it should be written as dioic acid at the end. So, that is the family of the compound, but then the numbering should start from the side where you have the higher priority groups. So, from the right hand side we have at position number 2 we have this group, and from left hand side at point number 2 we have this group which is oxo. So, what we should write is this group being a larger group, we identify the numbering from the right hand side and write the numbers 1, 2, 3, 4 and 5. So, this becomes pentane dioic acid, and now we should try to write down the name. What is the configuration at 2? The 2 has a double bond which is in the Z conformation. So, we should first write the configuration of the double bond as 2Z. Then we try to write the name of the compound as on 2 position, this group being the aldehyde group, as a substitution we should write it as a formyl group. So, it is 2-formyl. At 3 position we have hydroxy. At 4 position we have oxo, then we have pent 2-in dioic acid. So, this is the name of the compound when you have many functional groups which are significant here, like OH, aldehyde and oxo. So, with this I would like to give you some homework so that you can try to name some of these molecules. The first molecule is a bridged molecule that you may see here. The second molecule that I want to draw is the following. And the third molecule is this one. So, try to write down the names of these three molecules. Thank you.